Hello, everyone. So yeah, my name is David, and um, whatever your English is like, it is 10 times better than the 4 French words that I know. So thank you all for coming, though. How many people played, or actually, we'll start with a really easy question. How many people are comfortable raising their hands? Go ahead and raise your hands. Okay, we've set our baseline. Now we know exactly how many people raised their hands, so I can have my baseline all done. How many people played video games as kids or even as adults? Okay, just about everyone. So I also play video games, and one of the games that I got when I was about 15 or 16 was a game for the Nintendo Entertainment System, or the NES, and that's actually the inspiration for this talk. It was the original Legends of Zelda, and that game was incredibly frustrating. I spent hours trying to figure out how to play the game. And eventually I learned that no one actually got through the game by themselves. They all had a game guide. And that game guide would tell you to do certain things so that you can find the sword that's hidden in a wall and all sorts of things. So today I'm going to be your game guide for vector search. So my name is David Tippett. I'm a senior developer advocate, and I work on open source OpenSearch. So primarily on developing the open source project and getting it socialized for the world. And while I work for OpenSearch, I'm actually not going to talk exclusively about OpenSearch today, because the truth is, OpenSearch isn't always the best vector search engine that you can use. So feel free to connect with me if you would like. Also, my background wasn't in search. My background was in business. I was doing data engineering, network automation. So when I came into OpenSearch over 2 years ago now, I had a really hard time understanding what vector search was. How do I use it? What does it do? What does it not do? When do I use different technologies? And that's part of the reason why I brought this guide together. So let's go ahead and get started. Ooh, little delay. Oh, no, I forgot. I did these slides while I was sleeping still. So we have 3 different levels of vector search: beginner, intermediate, and advanced. And hopefully you'll find yourself identifying with one of these levels. So let's start with beginner. Our beginners to vector search, they are looking for a lot of different things. They're looking for user-friendly interface. So if you're new to vector search, you might not know what a vector is or how it's used. So you want something very simple and straightforward that you can maybe click through to get into vectors. A lot of our beginners to vector search are looking for pre-configured models. They don't know which model they need to choose. They just want a model that works, that can do sentence embeddings generally. So they're looking for something that is very easy to go out of the box. Then also, they might not know all the different ways that you can compare vectors. You know, there's like cosine similarity. So they just want something very straightforward that can get them started with vectors. So one of the things I recommend to people who are beginners is use the vector search engine that is closest to your data. So many of you might have data that's in Postgre, or maybe the data that's in Redis. So these all have vector search engines built in. So we have pgvector for Postgre. Redis has their vector engine. So use what is easiest to get started with when you get started with vectors. So that's our beginners, right? It's just getting started, getting warmed up. Let's look at our intermediate users. The intermediate users, you've started to see how vectors work. You're starting to understand the different methods. Maybe you've seen some issues with vector search. You say, oh, well, when I do this search, you know, it's not returning me the vectors I expect. And a lot of times, this is because certain models might be trained to do either just one specific task, or they might create embeddings that don't represent your business, you know, especially if you're in law or if you're in deep sciences. So our intermediate users are looking for a whole selection of models that they can run. They might be looking for connectors into different models, so into Cohere or OpenAI, SageMaker, Bedrock. Our intermediate users also are looking for some more advanced options. So here, maybe you know that, let's see, you want to do filtering on your data. Maybe it takes a while for your vectors to return, so you want to apply filtering. So our intermediate users are going to be doing things like that. You're also looking for some more metrics. You're looking to understand how long your queries are taking and why they are taking that long. And then finally, you're looking for integration. So at the intermediate level, this is where we see most people moving away from, the vector engine that's embedded in Postgres or embedded in Redis, and having a dedicated search engine. So these are people who are going to be deploying OpenSearch, Weaviate, Vespa, Pinecone, etc. So you'll have your primary data store, wherever that is, whether that is SQL Server, Oracle, and then you'll be building jobs to ingest them into the search engine, which is why the integration is really important. You don't want to have to build that yourself. You want to have tooling available to get that in. And actually, I mentioned Postgres earlier, which is interesting because there's a PG Sync, is a library for syncing Postgres data into OpenSearch. So our intermediate users are, building along the lines of, very, what is the word I'm looking for? They're more interested in figuring out what is relevant to their users and tuning that. So these are our tuners. And then finally, we have our advanced users. So you and your company might be an advanced user if you are fine-tuning models. So for those who don't know, model fine-tuning is when you take a already existing model and then you train it on your own data to basically give it the understanding of the words that you use. So deploying custom models is a really key feature. And one of the challenges with deploying models is it can be difficult to do scaling. So search engines like OpenSearch have mechanisms to actually be able to deploy and scale your models if they're in the PyTorch or the Onyx format. So this is one of the things our advanced users are looking for. Another real big one is scale and understanding how your application scales, which is funny because Cedric was just testing this earlier with terabytes of data. I'm going to say terabytes. Was it actually terabytes? Yeah, 10 terabytes in 6 hours. So again, you want something like OpenSearch that can scale to this high volume, or to just scale to meet demands. Maybe your search users are quiet during the night, and then at 8 o'clock in the morning, they start doing searches. So we want to be able to understand and scale your application appropriately. Additionally, they're looking for complex query capabilities. So say, for example, you are a modern search app, and you want to do both keyword search or BM25 search and vector search at the same time, because you know that hybrid search typically produces better search results than just BM25 or just vector search. So you might be looking for something like a search pipeline. This lets you put all of that logic into your search engine. So your users aren't having, or your internal users at your company, they don't have to figure out vectors for themselves. They just use your search endpoint. It comes in, it creates the embeddings inside of OpenSearch, and then it will search both the vector store, BM25 store, and merge the results at the end. So this is one of the things that our advanced users are looking for. And the same, lots of API access. Our advanced users typically are tuning things. They're tweaking to get exactly what they want out of the search engine. So I'm going to go back real quick for a half second. How many people would say they're probably in the beginner search level? Okay. Intermediate? Okay, all right. How about advanced? We have one advanced. That is very good. Congratulations. I have, hold on. There are at least 2 more chances to get a book. Here you go. I would run the party for you. You're a competitor. No, it's okay. That's okay. That's okay. No problem. See, this is the wonderful thing about being on the open source side of things is I don't care. I love anyone who's trying to do search, and that's part of the reason I built this as well, is there are valid uses for other search engines within the, I want to say ecosystem, but that is a 4-letter word at Amazon. So we don't say ecosystem, but within the search space, we'll say. So next, we're going to go and we're going to choose our route. So these are 4 kind of different personas that companies might fall into. We have the real-time wizard, big data hero, our fast iterating feline, and our methodical monk. And we'll talk a little bit about what each one of them does. So we'll start with the real-time wizard. So your real-time wizards, these are the people that have very, very stringent concerns about how data is updated. They need to know that when your data is updated in the system, that it is immediately available across all of your replicas. So these people are typically in like finance industry, where if a transaction is made, it needs to be made and immediately available. That way someone doesn't end up with a negative bank balance. The same, it's often advertising technology. They have very strict requirements around what latency they can have, only 10 to 25 milliseconds. So these are our real-time wizards. And a lot of times you might hear someone say, oh, you can use any vector search engine, but the truth is most vector search engines do not have the data structures that they need to guarantee that those transactions can be ACID compliant or immediately consistent. So I would not recommend using something like HNSW or IVF, which we'll talk about a little bit more. They're not going to be able to give you the guarantee. So for our real-time wizards, I often recommend checking out either Vespa or Pinecone. Those are both fantastic vector search databases, and they have the data structures needed to guarantee that when a document is updated, it's updated across all of them and consistent. So next, we're going to talk about our big data heroes. So our big data heroes are people who are ingesting terabytes of vectors. And one of the challenges with vectors is they are very memory intensive. You need a lot of RAM to work with them. So it can be very challenging with things like HNSW to fit all of your data into memory. So as a result, a lot of times we have some different recommendations for people who are doing large data. The first is, I would suggest IVF. So IVF is inverted file indexing, has a really efficient way of managing your vectors. One of the challenges, though, is, sorry, I'll get to that in a second. So IVF can reduce your memory foot by almost 10x in some cases. So that is one of the technologies I recommend for people looking to get into big data with vectors. Another is product quantization. Anyone familiar with product quantization? Okay, so product quantization basically allows you to reduce the number of features you are using in your vector, or reduce the size and granularity of your vector. So it basically compresses your vectors down so that they can be smaller and fit better into memory. One challenge with product quantization is you lose precision. So the results you might get back might be a little bit less relevant. However, it's going to be okay because you have so much data that you cannot afford to have exact relevance. Or you will be spending lots of money to have exact relevance. And then another one is sparse vectors. So sparse vectors is another way to represent vectors. I'm not going to talk too deeply about that because it is in areas I do not understand super well myself. But anyone identify as a big data hero yet? Big data? No, okay, that's all right. Ah, there's a pitfall. Everyone goes, oh no, oh no, what happened? One of the things you really need to know about IVF in particular is, oh, welcome, it's okay. One of the things you need to know about IVF is it has a training phase. And that training phase takes a sample of your data set, maybe 20%, and it uses it to create buckets for your data. And one of the challenges is, after a long period, maybe one bucket gets really large, one bucket gets underused, and that can affect your performance. So that's one thing that you need to know when using IVF. So now we're going to talk about our fast iterating feline. And these are our startups. These, how many of you are in a startup right now? Startup? Okay, yeah, a few of you. So your startups, you need to be able to deploy vector search in maybe a sprint or a couple of weeks. And once it's there, you can show your CEO and he's very happy, and then you're done with vector search. Well, no, not really. But anyhow, so our startups are looking to be able to move quickly. And it's very important to be able to test changes and make changes on the fly. So there are a couple things that our startups or our fast iterating felines should be looking for. The first is connectors. Connectors into places like OpenAI, Cohere, SageMaker are really important so that you can try different things quickly. You can swap out your connectors and begin to test and see which models are producing the best results. Another thing is a reingest API. So this is something that not many people think through. However, when you're testing, you don't want to have to reingest all your data every time from the source, because that can take a really long time. So having a reingest API built in so that you can test iteratively and make changes, reingest into a new index, allows you to significantly speed up your ingestion time. And then another one is HNSW. So HNSW is a way of, we'll say, bucketing vectors so that you can do vector search efficiently and not have to compare all of your vectors to each other every time. It's a general vector search sharding algorithm, I guess is probably the right way to describe it. So that's what I generally recommend to most people that are just getting into the space, or maybe they're a startup and they're iterating quickly. But there's another pitfall. Say, oh no. All right, thank you. One thing that's really important to note is vector search, like I said earlier, is very memory intensive. And HNSW is probably one of the more memory intensive ways to store vectors. So it's very important before you get into your vector search to understand your vector index size, which you can calculate. I'll give you some formulas at the end. And then another one is make sure you're using the right instance. So I saw this recently in OpenSearch where someone was deploying it with a M5 4XL, which is a CPU optimized. It's $1.66 per hour. We moved them to the R instance, and they were able to cut their costs in half and double their speed. So the R instances are memory optimized. So it's very important to understand that vector search doesn't work the same way that your traditional BM25 search does. So you have to change how you think about your instances. Although for BM25 as well, it's fairly memory intensive as well. But our last one is our methodical monk. Oops. So this is people who work in back-end IT at big companies, and like I did before, I worked at a finance company that wasn't really fintech, or they weren't doing anything cool or exciting. They just used features that worked for them. So the methodical monk tends to be bigger, slower-moving companies, and what they really want is to make sure that their search engine is going to meet their requirements. And those requirements oftentimes are compliance, auditing, security. So it is important to go through these and make sure that your search engine matches your requirements. I put FedRAMP and HIPAA, which I think are both US mostly, but SOC 2, do you guys use SOC 2 here? No. I probably should have localized this deck a little bit, but federal requirements for data security and privacy. So it's important that that can be matched. This is where you see fine-grained access control being really important. So that's FGAC and that is all the way down to being able to control which fields show up in documents that your users can see. And then I'm going to go back real quick. So how many people would probably identify with real-time wizard? No real-time. All right, big data again. Show your hands one more time. All right, big data. Okay, actually, I think that's more than before. How many startup? Okay, startup. Okay. And then how many people just work in back ends doing just some more slow and methodical search? Okay, awesome. So welcome. I'm going to give a couple recommendations because I always forget. I'm supposed to be recommending products each time I go through. So for the real-time wizard, again, that's going to be your Pinecones, your Vespas. Those are really good search engines for doing real-time updates. Big data heroes, I'm going to recommend OpenSearch, of course, because OpenSearch is great. Some other great ones, though, Weaviate is starting to do a lot more at scale, as well as Quadrant. Quadrant's used a lot in scale activities. For our fast iterating felines, I'm going to recommend OpenSearch, of course, because I think we're really good at that. And also, one of the other ones is Weaviate. So Weaviate has done a lot in their developer ecosystem with Llama Chain, Lambda Index, Haystack, to make Weaviate very easy and accessible. And then for the methodical monk, I actually don't generally give recommendations because auditing requirements are different per country. So it's just really important to do that due diligence ahead of time and to understand which search engine meets those requirements. And finally, I'm going to put up this QR code. So this goes a little bit more into all of the different technologies I mentioned, like HNSW, IVF. It provides some calculations that, yeah, absolutely. It provides you some calculations so you can figure out how much memory do I need for my search index. And with that, thank you. Does anyone have questions?
Should we leave the question till the end? Or?
Yeah, no, this is the end. This is end of, yeah. So do you have questions?
Yes. I'm pretty new to OpenSearch.
Yeah.
So from what I understood, that it is pretty much vector search oriented. Doesn't it allow semantic search? Or?
So OpenSearch is actually more of a metadata and storage engine, which sounds very strange, but I say that because what OpenSearch does is it manages the scaling of different things. So for BM25 search or traditional keyword search, it manages leucine charts. For vector search, it actually uses FICE, NMSLib for its vector search, and it manages the scaling and distribution of those indexes. So OpenSearch does search, traditional search, it does vector search, it does semantic search, it does all of these things. And actually, a lot of people use OpenSearch for observability as well, which is one of those interesting things because all logs are words. And turns out to find words, you need a search engine. So that is why a lot of people use OpenSearch for observability.
Yeah. I come from the observability
side
of the world. I use Elasticsearch.
Yeah.
So what I'm asking is, do you recommend using the vector search in this kind of
in observability?
Yeah.
So you can actually, a lot of people in the security space will actually create security embeddings, and they'll use those to match against different rules and try and understand what is going on in their system and to raise alerts or warnings. So I am starting to see more people in the security space. Observability, probably a little less. But OpenSearch does have a lot of other features for observability that are helping us to stand out, like segment replication is a really big one. It's allowed us to cut in half, basically, the amount of CPU you need to do ingestion, which is really huge. I mean, to say that it's a lot. So, but yeah, there's definitely a lot, but vector search may be on the lesser side of things. Yeah. Yeah, for sure.
When you talk about vector searching, you always talk about the plugin that does the embedding.
Yes.
So in your case in OpenSearch,
yeah,
if you have to give a percentage in terms of performance,
yeah.
What is the side that controls the performance of the search or the ingestion and search? Is it the package of the embedding, or is it the cluster behind?
I think that's, I hear your question. So you're asking when people are doing vectors, is it the OpenSearch the biggest challenge, or is it the connectors? Or
Exactly.
okay, yeah. So that's most people that I see doing vectors are using models outside of OpenSearch. So a lot of people are using Cohere or SageMaker, and those also manage the scaling of models. So that is the primary way I see people using it. There are several people, like startups, that are building their own custom models, and maybe they are deploying them with OpenSearch. But you hear less of those stories because they don't really talk about it super much, like we hear from our customers. So yeah. Does that answer your question? It's okay.
Because like if I'm going to use vector search,
Yes.
should I worry in a studies like phase? Should I worry more about the mod that I will be using? Should I worry more about if I'm using on a premise?
I see.
Should I worry more about the structure or the high end, which is the cluster?
Okay. So when it comes to like on-premise usage, your biggest bottleneck is probably going to be ingestion, because that's where you're going to see the most coming in. And that is where the model is very important. The model that you're using, the service as well. When it comes to the search time, it's fairly straightforward to get the search performance that you need out of OpenSearch. More often than not, it means adjusting to the right memory size, having the right number of replicas. So yeah, for the on-premise user, probably the model is going to be the biggest bottleneck. Yeah. Yeah, absolutely. Any other questions? You guys are too good. Oh, yeah.
Question about how you deploy a model inside OpenSearch.
Yeah, absolutely.
And what constraints you have in terms of what kind of model you can deploy inside. Because for me, it's a huge benefit to deploy the model inside the ingest pipeline somewhere.
Yeah.
Instead of having to do individual calls to infer a vector for each model.
Absolutely. So OpenSearch has a lot of constructs actually to help with model deployment and distribution. So starting with how you deploy models. So basically there is an API endpoint to either upload your model or specify an HTTP endpoint to download your model from. That downloads it into an OpenSearch index actually. And then from there are two ways you can deploy your or two types of models that can be deployed. We support PyTorch and Onyx, which is ONNX. Those are the two types of models we support deploying in OpenSearch right now. And one of the interesting things is when you're deploying your models, you don't necessarily want it available on every node, right? That could take down the performance of your entire cluster. So what we've done is we've created a tag that you can apply to your nodes. And maybe 3 nodes will be ML nodes, and they will get the model deployed to them. Then on the access side, we have security permissions. So only certain users can access those models, which is really helpful, especially when it comes to compliance, especially if you have proprietary models. So that is how we manage that. As far as past that, OpenSearch doesn't have any auto-scaling mechanisms for models. So it is important to do testing ahead of time. Say, this is our production workload. We're going to create a production level cluster and make sure it can handle the volume. Yeah. And then there are also some mechanisms internally to say if a model stops responding, it can restart it, or it can attempt to do other things, other remediations. That's a great question. And he already had a book, so you get a book as well. Cool. Yeah.
I hope it doesn't overflow.
No, it's okay.
So you mentioned the cybersecurity use case.
Yes.
So I come from that space. I worked at a startup where we basically ingested and analyzed terabytes of logs, so mostly network logs, DNS, but also a lot of text, SSL certs and things like that. And we had to kind of combine multiple data sets. So logs that are kind of textual, and then you had blobs of data.
Yeah.
So back in the day, we used like Hadoop, Elasticsearch, and a few other texts.
Yeah.
So in the current state of things, if we were to redo things,
I
mean, I exited the startup, but If I was to do the same thing with OpenSearch,
Yeah.
what are your thoughts or recommendations?
No, I think that's phenomenal. One of the really interesting things, and this is something that you probably ran into with Elasticsearch, is when it comes to data that can go into OpenSearch, OpenSearch acts a lot like a NoSQL database, right? So it doesn't necessarily do joins very well. You have all your data stored in an index, and it is a more flat index. So what OpenSearch actually just recently rolled out is a connector into Spark. And what this does is it allows you to create these views of your data, basically, where the data gets ingested, it gets put through Spark, which does aggregations, joins, merges, etc., and then can create a materialized view. So that is probably what I would recommend. So that allows you to have the flexibility of OpenSearch as a search engine, but also get you some of those big data capabilities that you see with Spark and Hadoop. Maybe I actually don't know if Spark quite gets to Hadoop scale just yet, but I'm not super much in the observability space. But that was one of our more recent releases as well. That's actually for the security reason, because we had several security researchers saying, you know, a lot of times I'll aggregate this data. How do I do that in OpenSearch? And this was our solution for that. Yeah, for sure. And you get a book as well, because now I'm out of books and I don't have to bring these back to the US with me. Thank you. All right, any other questions? Those were really great.
Now there's no books anymore.
Yeah, I know there's no more books. Sorry, no more incentive. Awesome. All right, I'm going to wrap up here. Thank you all so much. And